Dumb. Phoenix. March here.
Confidence intervals, that's what we're going to cover this chapter. The first part of this isn't all that real difficult. We're going to cover this first section in two separate sections. If you wanted to title it, you can just title something confidence intervals. That's what we're going to be covering today. Throughout the chapter, we're going to learn about confidence intervals for a mean, confidence interval for a mean for small samples, confidence intervals for a population proportion, which is just percentages, and confidence intervals for variance and standard deviation, which sometimes we get to, sometimes we don't. This year we are going to get to it. That's why it's in red. So confidence interval of a mean for large samples. Some of this is sort of hard for me to explain. Don't write any of this down because we're going to go over all this. All right. First thing you're going to do, you're going to find a point estimate. It's hard to explain because you sort of need to know it all at once. But I can't explain it to you all at once. I got to explain it to you as part. So by the time we get to the end, hopefully you'll be all right. A point estimate is just what you're looking at. Something that you're looking at to decide this is what we're estimating, and how good is it and everything else. Margin of error is exactly what it sounds like. How much off are we, or how much off do we think we can be? We're going to construct, and this is going to be everybody's favorite. We're starting to do this, and for the rest of the year, we're probably going to be doing this. You're going to have to write sentences, and I know that just kills some of you that you have to write out a sentence. But you're going to have to explain stuff, and I'm going to show you how to explain it. It's going to be writing the same thing over and over and over again. And if I have to deal with Brian back here that I can't read his writing,
Perfectly fine. There's nothing wrong with this.
know that on the next test, when we have to interpret and it says interpret, and I see this,
Completely legible.
I'm not reading it. It's just going to get marked wrong.
That's what my anatomy paper looks like after you're done.
That makes sense.
That's how he writes, I swear to goodness.
He can't even do a check mark. It just.
That's getting bad. So, what we're going to start off with is the mean. We're not going to know the mean of the population. We usually don't ever know the mean of the population, just for the simple reason that we can't find the population. We can't do everything in the population. Not falling for that. Put it away. Oh my goodness.
I was in a serious pool match, dude.
Determine the minimum sample size. Today we're probably not going to get to that part. All right? Unless everybody gets on my nerves, then we will get to that part. We're going to stop about halfway through and not get to that part, and we'll do that next week.
Oh, I'm sorry. I thought they were supposed to be around the 12, so that's all right.
Statistical inference. A statistical inference, remember, inference is just us sort of guessing and putting our thoughts onto a population. What we think is going to occur. So we're going to use a sample statistic to estimate the value of the population parameter. Remember back at the start of the year, we haven't done this for a while. Statistic goes with a sample. Parameter goes with a population. We can make an inference when our sample size is greater than or equal to 30 and the sample is normally distributed. Or we know the standard deviation of the population. Normally, we will not know the standard deviation of the population. If we can't find the mean of the population, then we can't find the standard deviation of the population. So normally the two things that we're looking at is we want our sample to be bigger than 30 30 or bigger, I should say. And it should be normally distributed. Now sometimes they'll tell you, assume that the standard deviation is 12. So with this, we're going to deal with the mean, which for a population that's mu. We're never ever going to know what mu is. But what we're going to do is we're going to find X bar for our sample, and we're going to use that to make inferences about the population. All right? Now when we do this, does that mean that our X bar is always going to be exactly the same as what the population mean is? No. It'd be nice if it was, but probably not. All right? So if I ask each one of you to go out and pick 30 people and find whatever out about those 30 people and come back and tell me the mean of your sample, not everybody's going to get the same sample. Not everybody's going to get the same sample mean. But if we take all of those, we can sort of make some or have some idea about where the mean of the population should fall. Point estimate. Point estimate's just a single value estimate for the population parameter. Right now, what we're going to deal with today, we're going to deal with the mean. Then we'll deal with population proportion, which is the percentages. Then we'll deal with variance and standard deviation and so on, so on, so on. If we're dealing with the mean, the best point estimate that we can come up with for our sample is X bar, the sample mean. So in other words, all this is saying is we're not going to use sigma to tell us something about the mean of the population. That doesn't work. The best thing, if we take a sample, the best thing that we can use to tell us something about the mean of the population is X bar. So the mean of the sample matches up with the mean of the population. I know that seems like common sense, but sometimes math people think that you have to tell everybody exactly everything. What I was just saying a second ago, just because we come up with a mean for our sample, that's not going to be exactly the same as the mean for the population. If I sent all of you out and you found a mean, you're probably not going to find, there's not going to be one of you in here that find the exact mean of the population if we actually went through and found it all. Probably not going to happen. But we should be somewhere close. So if the mean of the population, let's say somehow we figured it out and it was 10, and Riley went out and the mean of his sample was 3,250, and the mean of the population was 10, I'd probably realize, yeah, Riley probably didn't put a whole lot of effort into finding his sample and doing all this stuff. It should be somewhere close. It should be a good estimate. What makes it valid? The sample statistic has to be unbiased, and all that means, or all that tells us for our mean, is we're not putting stuff into it to make it either overestimated or underestimated. This part here is pretty important. The bigger our n, so the higher n is, the higher your sample size is, the better. So the higher you can get in to be, if we could use a sample size of 6,000, then that would be a good thing. We use a sample size of 20, not near as good. So if I sent all of you out and you did a sample size of 30, and I didn't like the way the results came out, and I sent y'all back out and I said, all right, do a sample size of 50 this time, which one's going to give us the better results? The 50. So the bigger the N, the better. The less variable it is. So again, if we're doing that and we somehow figure out that the mean of the population is 10, if we do a size 30, you know, you guys might end up maybe, you know, some of you there, some of you in there, some of you there, some of you might come out clear, something like that. If we do a size of 50, we might end up with some of you in here, you know, where it's a little, everybody's a little more compact in towards that mean. Get out your calculators for me. On your calculators, take a minute or two. I want you to type this into a list on your calculator. We're going to use it several times today, so put it in a list where you can find it. Give you a couple minutes to do that.
All of those?
Yeah, all of those. You want me to read them off for you? Would that make it easier? No? All right. So then when you go to work for Texas Instruments, you know what you could do?
What?
You could,
Are we just putting it in one list, or?
yeah, just put it all in one list. The top's blue just because I didn't know how to change the picture. You could put an app on that calculator that we could do what with that set of numbers?
Take a picture.
Take a picture of it, and then it sticks it in there for us. That'd probably be a good idea.
Yeah.
You could maybe sell that to the TI and make you some money. They'd probably tell you that they've already, oh yeah, we've already done that, which would be a lie. But I think there's 40 of them, right? So when you get done, you should have 40 in your list.
We're just ready to go. It's the original list. Are we writing this all down in one list? Yeah. Okay, thanks. I didn't get it.
Yeah, I got 40.
The other thing, while we're waiting on everybody to get done, we're gonna need this. So if you got that somewhere handy, I highly suggest you get it out. We're gonna use it here in a little while.
Are we gonna go over this high school?
Maybe. We have time.
No, on Moodle I have an F. I have a 38 in here because it says it was an F on my test.
Oh, that is, I'll check it out, because I didn't put the test grades in there.
I know, everybody else is like, my test grade's not in there, and I'm like, well, mine is apparently. It says I got like a 6 or a 4 on it or something. I was like, that cannot be right, like, I knew some of those. I
supposed to be what? Not mean to you? When have I not been mean to you? When you do what? When you smile. When you smile, I'm nice to you. When you're coming here all crabby and stuff. On this, what we want to do, take this list on your calculator, go to, what is it, stat, the one variable stats, and you're going to put in, you know, whichever list you put it in, I don't know, whichever one you have to put it in, and hit enter. The very first thing, I think the very first thing says this, doesn't it? Summation X, is that the very first thing when you do that? No, that's the second thing?
X bar.
My fault. X bar is first? Or the second thing then, what's the second thing say? 5,200 and what? 32, anybody else get that?
Yeah.
Seems like I got, yeah, that's what I got. I was thinking I got something different, but that's what I got. So that's the total of all those numbers. If we add them all up, that's the total. To find X bar, we just divide that by, how many of them was there?
40.
We divide it by 40, which they already told you X bar. You could do it either way. What's that tell you?
130.8.
Say it again.
130.8.
So now I'm going to read this problem real quick. A social networking website allows its users to add friends, send messages, and update their personal files. This is pretty old because all of these, this is probably not talking about any of them that you guys use now. This is probably one of those real old ones. But same idea, right? Huh? MySpace or something like that. That's probably what it was. The following represents, I couldn't put MySpace in there though because somebody's going to try to sue me for using, you got copyright infringement. The following represents a random sample of friends for 40 users. Find a point of estimate, the population, point of estimate of the population mean. So what we want to find is X bar. Well, we already said, what is X bar? That's our population, or I'm sorry, that's our point of estimate. Now, just to be a smart aleck a little bit here, we know that this 58 probably represents who?
An old person.
Somebody that's mean and crotchety all the time, and that's probably like Ebersole, because he only has like, oh no, I'm sorry, I meant this over here, that's probably Ebersole. Because he only has like 51 friends. We know this right here is probably our good friend Jackie, because she's so popular. Everybody loves her because she's such a nice young lady, always sweet and caring. And
247 is Phoenix.
247 is Phoenix.
Yeah. He's too busy on social media.
Is that he can't do anything else, so he just gets on there and has all kinds of friends.
All kinds of dudes.
That's not what it is. That's all we're going to be doing, or that's part of what we're going to be doing. So that's what we're looking at. We're looking at that 130.8 as our X bar. That's our point of estimate. Now, do we know that the mean of the entire world that's on this website, whatever it is, that they average 130.8 friends or whatever? No. But we're saying that it should be somewhere close to that. All right? Market researchers use the numbers of sentences per advertisement as a measure of readability for magazine advertisements. In other words, if you see an advertisement, and I know probably none of you has read a magazine in your lifetime, because you all look at the internet now, and that's where everything's at.
How young do you think we are?
So you read a magazine and you look at the advertisement. If you're making an advertisement for this magazine or for something online, and it's got 3 paragraphs down below it. Are you gonna read that advertisement?
No.
Probably not.
Yes.
Alright? Some of you might, most of you probably won't. So if it's got a picture, Jackie's looking at it and it's got a picture of a spectacular looking young man in the picture and 3 paragraphs, she's probably not reading the paragraph, she's just looking at the cute young man in the picture, right? But if it's got fewer sentences in it, then you're more likely to read it, and that's what this is saying. The following represents a random sample of the number of sentences found in 50 different advertisements. Find a point of estimate, population, of the population mean. So we're going to find X bar again. What would we do with all these to find X bar?
Go to the list.
Add them all up and then divide by how many of them there are. And I'm not going to make you do this one, we're just going to do it together. I added them all up and I got 620, and there was 50 of them, they told us that. So the average has about 12.4 sentences. If we look back at this, Sean's writing an advertisement for his business, and Sean writes that one. What's probably going to happen to Sean?
It's going out of business.
He's probably going out of business because ain't nobody reading. All right? You want to keep things, especially with Squirrel, with everybody's attitudes today and stuff, you want to keep things short and sweet.
TikTok.
This is the other part that we're going to do today. I'll try to move this. This is very, very important. So write this down. An interval estimate. An interval estimate is an interval or a range of values used to estimate a population parameter. We're going to find these intervals. One thing we're going to do is find the point of estimate. Then the other thing we're going to do is find the interval that's going to give us the range that our mu is going to fall in or should fall in. This is, all you really have to write down is this. We're going to talk about this and it'll make more sense here in a second. Just write down what that is. The probability, when we just did that last one, the probability that the mean of the population is exactly 12.4 is 0. So if I send all you out and you find your X bar for your sample, and you come back and you tell me what your X bar is, the probability that that's the mean, the mu for the entire population, 0 chance. All right, it could be really, really close, but it's probably 0% chance that it's exactly that. And that's what this is saying. So what we're going to do is we're going to find an interval from some number to some number, and we're going to say something about that. And that's where you're going to have to interpret it. We're going to say that, hey, we're pretty confident that 12.4 is not the mean of the population, but we're a certain amount confident that it falls between here and here.
So like standard deviation.
So what?
Like standard deviation.
Sort of. That's sort of what we're going to use. Now, some of you will say, well, why don't we just go from 0 to 1,000 and we could be 100% confident that it falls in there? And that's true. But that doesn't do a whole heck of a lot of good. All right? That doesn't tell anybody anything. How confident do you want to be that it's within there? That's where things change, and that's where we're going to use your tables that we have there, and I'm going to explain that to you here in a minute. So to form interval estimate, find your point of estimate, goes in the middle. You add or subtract your margin of error, which we haven't done yet, which we're going to do here in the next slide or two. But these are the two steps. It says add or subtract. It probably should say add and subtract, because if we subtract, we find the low limit. If we add, we find the high limit. So right here in the middle, I'm going to write in 130.8. That's what we came up with on that first one for the MySpace or whatever it was. Somebody help me out. What's 130.8 minus 15.7?
115.1.
So that's going to be one side of our interval. Add those two together. What's that give us? 140.
6.5.
That's going to be the other side. So we found X bar. It's right here in the middle. And we're saying, hey, we're not sure the X bar is exactly the same as the mean of the population, but we're pretty confident that the mean of the population is going to fall in that range somewhere. And we're going to be able to say how confident we are. We're 95% confident, 99% confident. Are we ever going to say that we're 100% confident? Never. It's like a weatherman. All right? They ever tell you that there's a 100% chance of rain? No, they don't. Never. You know why they never say there's a 100% chance of rain?
Because they might be wrong.
Because they could be wrong then. If they tell you it's 99% chance of rain, are they ever going to be wrong? So what if they told you today there's 99% chance of rain and it doesn't rain today? Were they wrong? No, because they also said that there was 1% chance that it wasn't going to rain. So they were still right. That's why it always kills me. Stupid weathermen, they're always wrong. No, they're never wrong. So before finding the margin of error, you must decide how confident you need to be for the interval. I would write this down, confidence level. That's important, and confidence level is going to be represented by C. The ones that we normally use are these three right here. We usually want to be 95% confident, 90% confident, or 99% confident. The key part on this slide is that level of confidence. Level of confidence is represented by C. That's the probability that the population parameter, the mu that we're dealing with right now, is in the interval that we make. So we're going to be 90% confident that it's in that interval. We're going to be 95% confident that it's in that interval, so on, so on, so on. If we're 95% confident, if we're 90% confident, what we're doing is we're splitting off our normal curve here, and we're saying that we want 90% to be in there. Well, if there's 90% in there, how much is left over for this tail out here? 5%. How about the other tail out here? 5%. So 5% on this end, 5% on that end, it's going to fall outside. 90% of the time, though, it's going to fall inside. I'm just trying to show you why these are the ones that we use. 95%. So if we want 95% in the middle here, what's out here? 2.5%. About here? 2.5%. All right, so 95% of the time, it's where we want it to be. Each end, 2.5% of the time, it's on the outside. And then the last one, 99% of the time. So we want 99% in here. My pen won't work there. What percent's out here? Be careful. 0.5%. Now you got to be careful because it's 0.5%. But if we're looking on our charts and stuff, that'd be 0.005. And 0.5% or 0.5% on this side. That's our confidence level. Notice what happened to our interval as we made the C go up. What? It got bigger. So think about it this way. And this will make a whole lot more sense probably when I do it this way. If I got 50 here, 60, 70, 80, 90, 40, 30, 20. And I say 50 is our point of estimate. That's the middle of our stuff here. So I should probably go out to 10 just to make it look like it's the middle. If that's our point of estimate, how confident am I going to be that the mu falls in that range? Am I going to be real confident or just a little confident? Just a little. So that might be like the 90% confident. But if I widen that, am I getting more confident or less confident? More, that it's going to fall in there. And if I go way out here, now I'm really, really confident that it's going to fall in there. So that's what you're doing here. As you go up for your percentage, as your C goes up, you're widening your interval and saying, yeah, now we're really confident that it's in here. Just like with this, I could go 0 to 10 million. Now I'm probably about 100% confident that it's going to fall in there. All right? But does that do us any good? And that's why we use these smaller ones to come up with how confident are we. On the charts, if you look at your charts, down at the bottom left right here on these charts, so that you don't have to do this every time yourself. You can just look right there on that chart. Those are called critical values. For this section, those are the numbers that we're going to use all the time. So a Z-score for a 90% confidence level is 1.645. So in other words, if I'm on my normal curve here, and I want 90% to be in here, this number is 1.645 Z-score. What's this one over here? Negative 1.645. That's all that's telling you. So you're probably going to need the plus and minus. It doesn't give it to you on there for each one because they're expecting that you should be smart enough to know that that's the way it's going to work. So that's right here. Those are called critical values. And all that's doing is saying, hey, if we use this as our critical value here and here, 90% of the area is falling between those two. So when we go to find a Z-score, if we're trying to find a critical value Z-score for 99%, it's going to be a positive and a negative 2.575. And that's what we're going to use as our Z-score to figure out some of this other stuff that we're going to do. Again, you're using this one. Not this one over here, that's for something different. We're going to talk about it in other chapters. They're sort of the same thing, but just a little difference. So those are called your critical values. Stuff outside of it is improbable. Stuff inside is what we think is probable for our prediction. Now I'm going to run through this stuff pretty quickly. hopefully, we just did all this, you just subtracted off there and so on and so on. Subtract it off and you can find half on one side, half on the other. We just did that for all three of them a second ago. Your sampling error. Sampling error. Sampling error is the difference between the point of estimate and, let me get all this, I went too far, and the mean of the actual population. Now, as you write this down, and some of you are going to be upset with me here in a second, I would write down just the first sentence up there, sampling error, and then what that says, and then I would write down X bar minus mu. And the reason that's all I would write down, what do we know about mu? Can't find it. So, are we ever going to be able to find the sampling error? Can't really find. You can't really find the sampling error for your sample because if we knew what mu was, we probably wouldn't be doing the samples. And no reason. And since X bar is going to vary, if I tell each one of you to go out and take a sample, every one of you is going to come back with a different X bar unless you cheated off your neighbor, right? So since everybody's going to come back with a different thing, the sampling error is going to be different for every single one of you, even if we did know what mu was. Now, we can't find the sampling error, but what we can find, and this is important, is the margin of error. I'm going to put this up here so you can write it down. This is the other thing. Margin of error, and that's E. So you remember on the test here a while back when I had an E on there and nobody knew what it was and I told you to get rid of it? That's what it was, margin of error. I think I told you to get rid of it, or did I just tell you it was something else and told you to write that down or something? I can't remember. There's been a couple things I've lied to you and said, oh yeah, just write this down.
Degrees of freedom, one of those.
It's way back a long, long time ago it was, but for the last one, no, degrees of freedom.
No, I'm not saying not that. I'm saying, did you lie to us about that?
Yes, I lied to you a long, long time ago on the first one, on the very first vocabulary test, because we hadn't really dealt with it a whole lot yet. But then on the next one, no, we had dealt with it, and DF does mean degrees of freedom.
He's broke my
I don't remember what I lied to you and told you DF was the first time, but
You just lie to us all the time.
yeah, a lot of times.
Can't trust you.
You remember when I told you how much I liked you and stuff?
There it is. How do I know if I'm doing math right? Could be lying about all this. There's a lot of big conspiracy.
No matter how you do that math, 1 plus 1 still equals 2, so as long as
Yeah, but you can write it
as
out.
long as you're getting
proof.
the answer.
How do I know the answers are correct if I'm going about them wrong? You all are sheeple. Following the man.
How long have you been teaching here?
Like 23 years, 22 years.
You've been lying to young, impressionable teenagers.
Out for 20 something. I saw you in the yearbook of
Yeah,
2009.
Look exactly the same.
You do. You have not
Was
changed.
I supposed to look different? You want me to go get plastic surgery?
I was expecting a
No, they
mullet.
want you to look old.
Oh, look old.
Yeah, you're
Or look younger
and
than.
youthful.
Okay,
well, that was
younger than-
rude.
You had a little bit more hair.
Yeah, that's probably true.
You did have a little more hair. I was expecting long.
It's
hair.
not a big difference. How long have you
You
had that
guys
haircut?
don't realize that you're not
I don't. It's not
You're
even
not
really a haircut. My wife
healthy.
just cuts it and
Like,
I take a brush and I do this. And that's all I do to it.
I can tell.
Riley.
I'm being mean to you. I'm
Huh?
sorry.
You literally just told him he has.
I called you all sheeple, not him.
Okay, you're
He's the
really
leader.
talking about his hair.
Let's say,
He's doing pretty
Is
good
that
to lead the
standard
herd.
deviation? Cause I don't like it.
This,
Yeah.
I'm in
Yeah.
English.
that's sigma.
I can't write anything this time.
Oh, I think it's-
Alright, so margin of error on the last slide, it was sampling error. We can't find sampling error, but what we can find, I lost my paper. But what we can find is the largest possible amount that the sampling error could be, and that's called the margin of error. So we can't find exactly the sampling error, but we can find the largest it could be. And that's what this is, and that's what this formula is. I would not mess with that formula. Doesn't hurt anything to have it down there. This is the formula that we're gonna use. That's the real one that we're gonna
Okay,
use.
right, right.
It's fine to write both, it didn't hurt anything.
They're the same thing.
It hurt me.
They're the same thing, it's just one of them's expanded out.
Yeah.
This, if you remember sigma x bar, last chapter we learned that it was sigma over the square root of n, so we're just plugging in something that we already knew there. So you're gonna plug in here, that's your critical value, that comes from the little chart on your paper. So, I just left it laying over there, so if I look at McKenzie's here, if it was 90%, it'd be 1.645, that's what we put right in there. Our sigma here, for the sigma, we're normally not gonna know what the sigma is because we don't know the population mean, so we can't find sigma. So in place of sigma, probably most of the time what you're gonna put in there is S, which is the standard deviation of the sample. Alright? So usually, instead of sigma here, it's gonna be an S. But the formula calls for sigma, but we usually can't find that. And then the square root of n. And as you do this, what happens to your error as you get more in your sample? It gets smaller. So if you got 100 in your sample, and you got 1,000 in your sample, the error is getting smaller the bigger sample size you get. So again, this margin of error, sometimes called the maximum error of estimate or error of tolerance. Different books call it different things. We're just going to call it the margin of error. And we're going to use that margin of error, that E, we're going to use that to find our interval on our number line. Use a magazine advertisement data and a 95% confidence level to find the margin of error for the mean. I said this is the one you put in your list, so get it back out. Assume that the sample standard deviation is about 5. So they're telling you that the sample standard deviation is about 5. Somebody do me a favor. Punch in, because we put the list into the calculator. Somebody look on your calculator, do the 1 bar thing and see what SX is.
52.63.
So I'm not sure why they got the standard deviation at 5. What is it?
52.63.
Let's get rid of theirs and we're going to do 52.6. That's going to be our standard deviation. All right? So now to find the E, we want it 95%. So grab your chart, and on your chart, look at 95% and tell me what Z-score goes with that.
1.96.
1 point what?
96.
So that goes there, times our standard deviation, 52.6. Then the square root of our sample size. What was our sample size? How many did we put in that
40.
list? 40, is that right? Type that into your calculator. I would tell you, if you're typing this into your calculator, I would do it this way. 1.96 times that. I would hit equals then, and then hit divided by square root of 40 and hit equals again. And I know one of you is going to say, well, I could just type it all in this way. Whatever, do it. Don't care.
Why'd you tell us?
Because I'm telling you the way that everybody could do it, and we all get the same answers. But somebody's going to tell me a different way to do it. I don't care the different way. I'm
I
just
did it right, 16.
16 point what?
I think
Is that what everybody else got?
Yeah. Yeah.
So that's our margin of error. Now this is what we're gonna do with that margin of error, and there's like 3 different ways that you could write this on your paper. You could write it out as a sentence and put X bar, actually it wouldn't be X bar, it's gonna be the mean. The mean is between a certain number and a certain number, and the way we're gonna find that is we're gonna take our X bar number that we came up with. What was it? It was like 180.3, is that right? We're gonna take that number and subtract off what we just came up with. And on this side, we're gonna take that number and add on what we just came up with. That's gonna give us that. Another way you could write it, and I'm just doing this real quick, is you could do those same things, but just put it in a set of parentheses, like it's an ordered pair, and just put it in there without the X in it. Alright? A third way you could do it is on a number line. We sort of did this a second ago. Put 180.3 on this right in the middle. Over here, put what you get when you subtract the 2. Over here, put what you get when you add the 2 numbers, and then that gives you your interval. I know I went through that real quick, but that's just because I wanted to show you all this other stuff. That's what we're looking at. So this says 1.4. We figured out that was wrong because I don't think that standard deviation is correct. I think I used 2 different problems on this or something. Oh, that's why. I was using the wrong problem. So we just did this one. That's what we just figured out. 16.4. Is that about what we came up with? Yeah. 95% confidence interval. That was the 1.96. This is something out of the book. Let me get this up here. I would highly suggest that you write this down. That's the formula you're going to do to find your interval. That's what I was just saying on that other slide. You're going to take X bar minus your E on one side, X bar plus the E on the other side. Again, for some reason, I don't know, a couple of you complained about not being able to make the mu symbol. If you don't like making the mu symbol, then write it this way, with a comma in between. X bar minus E on this side, X bar plus E on that side.
It's a U. It's just a long, like a U, but it's, I don't know how to say it.
A U with the.
I didn't have any
You
complaint.
with the line.
I didn't have any complaint about making it. It was you guys that complained. And some of you complained that mine was crappy and.
You draw an M. You draw an M.
That's true.
You do draw an
I know what you mean by it.
Is that better?
M.
No.
Kind of looks like it.
That looks like half of a cursive F-I.
Let's remember that Ebersole makes up the test, and I'm going to start taking off points.
It's a very good cursive F-I.
If I don't like your mu, Michael, on the next test, minus points.
It's just a U.
You better find something that you can stamp it on there, because I'm taking off
Do
points.
you want mine to look like that? I can manage.
I want you to not complain and just
I'm
know
not
what I'm
complaining.
talking
It looks
about.
good. I complimented you.
All right. No, you said it looks like an FI.
Yeah, I said it's a very good cursive F-I.
That sounds like a complaint as far as the mu
Do
goes.
we need to write
I'm
this
sorry.
down?
Points off. Not really.
How's that not a compliment?
I could be guiding notes.
So what we're gonna do with this, we really don't need to write this down, it's not all that difficult. I separate this off. We're not using this formula to find S. We're either gonna use our calculators to find the standard deviation, or they're gonna tell it to us. So we could do all those big long charts from earlier in the year. We do have to find the X bar, so if they give you a list, you're probably gonna stick that in your calculator and find it that way, or add them all up and divide by how many of them there are. You're gonna use the table to find your critical values. Then you're gonna find your margin of error, your E, by plugging into that formula. No easy way around that. You just have to plug into that formula and find it. Then you're going to set up this to find your interval. Construct a 95% confidence interval for the mean number of sentences in a magazine advertisement. This is the one that X bar was 12.4. The margin of error was 1.4. We found it a second ago. I skipped over it. So all you're going to do here to find the left endpoint and the right endpoint is you're going to take your X bar minus your E, and over here you're going to take your X bar plus your E. And again, if you want to write it as an inequality, that's fine with the alligator mouse. If you just want to write it with the parentheses, that's fine also. On this one, what's 12.4 minus 1.4? So that's the low end. What's 12.4 plus 1.4? That's the high end. And if that's a 95% confidence interval, this is what we're saying. 12.4 is right in the middle. Out here on this end is 11. Out here on this end is 13.8. And we're saying the way we interpret that is we're going to say something like with 95% confidence. This is where you're not going to like me too much because this is what you're going to have to write out when you interpret this stuff. With 95% confidence, I can say, sorry, that's ugly. That, thank you.
I can't.
We need just to take Michael and Riley's mouth shut.
What did I do?
Michael is
What did I do?
He's like a former rebellion.
Say that the population mean is between 11 and 13.8. That's how you're going to interpret this stuff. So if we look at that, we make that interval. We're not sure what the population mean is, but we are 95% confident that it falls in that range somewhere. That's all we're saying. Nothing really hard about this. We did all that. Notice they wrote it different. We could have wrote it on a number line like this. 3 different ways we could do it. We could do it by the graph. You could do it by using the mu in the middle. You could do it with the parentheses. 4 different ways, I'm sorry. You could also wrote it that way. I don't like that way, so don't do it that way. Yeah. I'm going to skip through some of this. That's what your assignment's going to be covering. It's going to be doing that stuff, be able to interpret the results. Something I do need to say. When you're interpreting the results, it's incorrect to say there is a 90% probability that the actual mean is in the interval. That's not what we're saying. All right? You're not saying, hey, it's 90% chance that it falls in here. That means there's a 10% chance that it falls somewhere else. All right? We're saying that we're 90% confident that the mean is in here, which is, I know it's just wording, but it makes a big difference to the math. If you see stuff like this on some of your test scores and stuff, if you've ever seen this on like an ACT, an ASVAB or something, and they show the little bars and a lot of times they'll write it, it'll be sideways and it'll go like this. Some kind of standard test or something, it'll go like that. Guess what this bar represents? The mean, and then that sort of shows you where you're at. So if you're this bar, what's that telling you about you as far as that part goes?
It's like,
You were up higher than most people. So what it's saying is, hey, if that's the mean, your stuff was higher than most on that certain area. What's this one telling you?
Less.
You were low on that area. So if you looked at this, if we were looking at this, and we numbered these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you knew that you had to go retake this test so that you could get more money to go to college, which area should you study the most on? 3. Does everybody see that? That's what it's telling us. Which question? Sorry, I'm trying to figure out where I want to be on this stupid motion. Probably should have stopped here. This is one of the problems on your homework that I did for you. I think that is too.
Show the solution.
I think Jackie can handle it, so I don't need to do it for her, right, Jackie? That's your assignment, page 311, 1 through 28. 311, 1 through 28. If you relax for a minute, I'll find your test and I'll hand them back to you. Except for those 2 people who took it today, I don't have them graded yet.
I gotta give you mine.
You don't have to, I'll just leave the grade in
I would
there.
rather you.
I want some chicken nuggets. Somebody good.
Aren't you gonna work at 3:45?